Welcome to this session. I'm Paul Swaddle, Head of Technical Solutions at NBS, and this SIBC CPD is an introduction to the principles and purpose of specification writing. Every aspect of specification is project specific, but there are some structures and content principles which can be learned and applied generally. The focus is on NBS Chorus, but the same concepts could be applied to other specification outputs, and principles like good editorial practice apply to any project. Today's presentation has 8 parts. We'll begin with a short introduction to NBS. Before we get to Chorus, we'll consider what a specification is and why specification is important. We'll look at the benefits of using a master specification platform and how well-structured data and classification is a key foundation of better specifications. Then we'll consider core editorial principles and look at how information evolves across the project timeline in what's been called the golden thread, and also different types of specification too. Finally, we'll look at the development of the information model and where specification might go in the future. I appreciate those of you attending may have some or no experience of NBS, or may be new to specification, so here's a quick introduction. NBS is a technology platform for the construction industry, and every day thousands of users interact with NBS services to create specifications, find products, and develop digital models of information. NBS has built platforms focused around reducing risk through excellent guidance, access to standards, and world-leading software. Through direct links to manufacturers, NBS helped connect specification users with product information. In the last year, NBS became part of the Big Factor Group, a Swedish headquartered building information group, giving us the scope and resources to invest in the future. NBS was first published almost 50 years ago in paper form, and everything since then has been a form of technological evolution, from supporting the advent of office computing and modern desktop software to web technologies, databases with links to guidance and standards, and now fully into the cloud with NBS Chorus. But the core principle of standardized, reusable clauses of specification content that could be made project-specific, published, and kept up to date remains the same. NBS also generate industry-wide research and reports, including NBS National BIM Report, now the Digital Technology Survey, showing how organizations are actually implementing emerging technologies. And as a result of that research, some typical specification issues appear to be common across the industry. Feedback indicates that firstly, there's a lack of quality in many specifications created, either because they're DIY, often not clear enough or concise, and often using old specifications for similar projects. Time is a key issue for all project teams, and surveys suggest that most time is spent in the model environment and drawn information, leaving not enough time for the specification to develop, and instead it's often left to the last minute. Sometimes it's the most experienced staff that are put in charge of the specification because it can be perceived as a very complex task. It's worth saying that it should be given to somebody with a level of technical expertise, but it can be collaborative, checked and approved just like a drawing would be, and we're aiming with NBS to encourage junior teams to get involved in the specification process. Finally, it can be difficult for specifiers to define responsibilities for contributing information to the spec and to source that information, selecting the correct amount of data depending on the project stage. But to start, let's go back to first principles. What do we mean by this word? What is a specification? More accurately, we should say, what is specification? Because it's a verb as much as a noun. You might produce a specification as an issued document, but specifying will be an evolving activity across the project. Most simply, specification can be described as taking decisions, recording those decisions, and then communicating them to the right people. The first analogy I've always used to describe specification is ordering a hot drink. If you go into a coffee shop and order yourself a drink from the large number of options, you're defining a specification, and further along the counter, the barista either hands you exactly what you ordered or you can discuss changes. In that case, it's a verbal specification, whereas most of the data this webinar focuses on is written and contractual. The term specification is being specific about what you want. Or say you wanted a sandwich. If you choose, make, and eat the sandwich yourself, you don't need a specification for you. The specification is important, it's essential, as soon as you need somebody else to do work for you. what bread, what filling, whether it should be cut in half, whether it should be wrapped or left open. This is the process of making decisions and adding individual specific requirements. How do you specify what it is that you want, or what your client wants, without somebody being able to read your mind? Construction specification is just about the type and quality of the built environment instead. Finally, consider how you approach buying a new device or technology, like a mobile phone or laptop. You're likely to want to compare features between different makes and models, and you'll have some key criteria in mind that the device has to match or exceed, comparing battery life, screen resolution, camera quality, or weight. And increasingly, you need to know whether it's in stock, available, or more expensive. So these are all standard properties that can be provided by manufacturers and listed in standard ways. Shopping websites use exactly these same principles of standardizing their data to help you search and filter for what you're looking for. For the built environment, the specification is most often a document, but is increasingly now a data model or a database connected to model information, helping to ensure that the constructed entity, which could be a building, but could be another kind of asset like a park, a tunnel, a bridge, even an art installation, is of suitable quality and meets the expected design intent. The specification defines products and materials to be used, the standard of work required, any performance requirements that need to be met, and the conditions for carrying out the works. Ideally, it should be developed in parallel with the rest of the design process, not just part of the completed design, but forming part of the contractual and handover information for the rest of the project. So that might describe what a specification is, but it's also worth noting what a specification does not include. The project specification is a written description, and as such, in most cases, it does not include graphical or geometric information. This is best represented in drawings and models in combination with the spec. John Gelder, in his book Specifying Architecture, calls this the components of the description of the works, and suggests that almost always both graphical and non-graphical information is necessary. The text information provides the definition of quality and process, and the drawn information the quantities, position, assembly, and extent. Often on small projects, drawings used to be annotated, almost like a replacement of the specification, but this is impossible for larger projects, and even on small projects it's really difficult to keep things updated as things change. Nor does the specification generally include information on quantities of materials, variants of many repeated items like fan coil units or louvers, which are better expressed in schedules generated from the model information, and often bills and quantities or pricing reports provide cost data, so that tends not to be in the spec either. There's always changing factors that impact and accelerate the work that NBS do, and recently regulations and mandates such as the draft Building Safety Bill, helping you to build safer and provide the golden thread of information, influence the content of NBS. Also, sustainability credentials, ensuring we provide standards and guidance on targets and requirements towards the sustainability goals, but also industry, society, carbon calculation, reducing cost and water consumption. And finally, digital transformation. There's been a real workplace evolution, and there was a huge increase in chorus usage across 2020, working from home access being a major catalyst there. So why are specifications so important? What can go wrong? In 2007, a luxury house in Jersey was demolished, having sat unused for 5 years. The building had failed to meet the owner's expectations, and the owner sued the contractor, the architect and the engineer, and the project manager for a catalogue of errors. One of the significant issues raised was the lack of project documentation, in particular a written spec. As there was no written specification for the project, the architect was found to be liable for the failing and damages were sought. That's a major example of project documentation failure, but it helps to demonstrate the importance of a spec to ensure that the client's requirements are properly documented and met. There's examples of significant building failures like this in a range of public sector and private projects up and down the country. Specifications are vital in times of dispute, but their fundamental purpose is to provide a clear and complete written description of the works as part of the contract. And now there's even more urgency around improving various aspects of the building industry as a result of the London Grenfell Tower fire in June 2017, when 72 people lost their lives. This has brought a renewed, increased attention to specification, performance and quality. And in the shadow of Grenfell, a major independent review and report, the Hackett Report, was commissioned. That report, Building a Safer Future, concluded that the current system for ensuring fire safety, specifically in high-rise buildings, was not fit for purpose and recommended a full overhaul. And the government has accepted all 53 of those recommendations, and that has led towards the draft Building Safety Bill. But here are some extracts from that original document, particularly around the need for the golden thread, that key information is recorded digitally and maintained for the life of the use of a building through all of its phases, which is a subject we'll look at in more detail later on. It's also worth highlighting that in a lot of the business and industry reports about disruption, digital transformation and improving productivity in the industry, the need for structured data, standardized classification, comparative properties and quality specification is cited as foundational improvement that would result in cost and time savings and productivity growth, not to mention the general benefits for communication in digital platforms and collaborative projects. So let's go through 10 reasons why specification is important. The specification is your opportunity to document your or your client's requirements on a project. A good specification should be clear in terms of the levels of quality, materials and products. And just like our example about finding a new device earlier, the more specific you can be and the more informed choices you can make, the better the outcome. Drawing info can't convey all of your requirements. Even on BIM projects using the latest platforms where fully rendered designs contain all kinds of information, only specification can capture the quality of materials, workmanship and installation, relevant standards that need to be met, and many aspects which are never modelled, like mortar, wall ties, brackets and joints. Specifications shouldn't include cost information, but if well composed, structured and detailed, it's easy for a QS or contractor to price the job quickly and accurately. Expectations on performance and minimum levels to be achieved result in more accurate pricing down the line. If you can make reference to specific local standards or testing that are applicable to the job, they could impact cost too. Performance and quality can be cross-checked against the latest standards. If you're not keeping the specification references up to date or coordinating the model information, it becomes easier to challenge it and harder to enforce. Also, it has been tempting for organisations in the past to provide specs full of general clauses from previous projects or the whole of NBS content as a perceived safety net or catch-all. NBS templates are designed to be adapted, parked, edited, removed for the specific needs of your project. It makes no more sense to keep in clauses that you don't need or to understand than to send drawings of every detail you've ever designed. If in doubt, leave it out. Improving statutory compliance through the spec helps you avoid the legal implications or penalties and can reduce the risk of prosecutions. Defining requirements for specific standards, sustainability benchmarks or compliance with health and safety, and then adding the execution and verification will assist a project manager in determining and verifying that requirements have been met through testing. A good specification should serve as an on-site instruction manual. In stating clearly that the standards you expect the workmanship to be completed to, you're effectively providing links for those working on the job to follow. The specification should be available on-site as a reference guide for those standards. The specification itself should not specify method. The focus should be clearly on outcomes rather than the process by which they're achieved. We've touched on how you're better protected from risk by creating a robust specification, but specification also forms part of the contract documentation and therefore becomes legally binding in the event of any litigation. Hard coding specification requirements makes them harder to dispute and demonstrates you are considering the risks and issues ahead of time, clearly indicating your design decisions in writing. I hope you never do, but should you find yourself in the unfortunate situation where there was a dispute on your project, if you easily and quickly have a specification to hand, assuming it is correct and clear and accurate, you're in a stronger position to discuss what happened. It tends to end up far more detailed, but the spec is also an interpretation of the original client brief. It should be straightforward to follow through all of the requirements in the spec back to the fundamental requirements from the client. It serves as a written interpretation of that brief, and by ensuring that you have fully understood the client's wishes and the outcome or asset that they require, it's a key check on the performance criteria. The specification will not stay static once you've written it. It will evolve across the project timeline and beyond tender in theory to end up with an as-built version which accurately represents the choices made in the final asset. That specification will prove invaluable for asset managers, FM and maintenance teams to provide vital information about the building or asset when it transitions into use, reuse, and even through to demolition, presuming it's kept up to date with changes across the life cycle of the asset. Taking the time to collate accurate information, clear instruction, and minimal repetition will allow the contractor to proceed with little disruption, which tends to save time in the long term. Better specifications often reduce the need for questioning and meetings, often to clarify something that wasn't made clear or needs to be checked or discussed in detail, all of which adds time and costs to a project. In this section, we'll look at NBS Chorus in a moment and consider the types of specification we can develop. Our recent digital transformation demonstrates that we are capable of massive change. Moving to the cloud, as so many of us have done with many different products, means there's nothing to download, there's nothing to install, these platforms are accessible anywhere, and we're no longer tied to a desk to specify. We could be using a tablet on site, for example. It also used to be the case that there'd be a spec writer, often in the corner of the office, and that still persists in some practices and organizations, and in North America too. But Chorus is designed for collaborative projects, bringing the spec into the core of the design process and enabling everybody in the project to work together within the same project or on the same specification. And it's important to keep those skills developing and to communicate between the project members. NBS have been doing this same work of standardizing the specification process and providing robust technical information with our authoring teams for over half a century. In 2023, we'll be celebrating 50 years since NBS was published, and every day has demonstrated a desire to innovate, improve, react, preempt, and make the industry better. 1/3 of projects end in dispute, and 1/4 of those are linked to poor or missing specification. There's more than 8,000 changes every year to construction standards and almost 100,000 references in NBS. So if you're trying to manage that process yourself in standard specs in Word or sharing documents in Excel or by email, I implore you to consider NBS. It'll make you more efficient and reduce risk, which is going to have an impact not only on your own organization, but to improve the wider construction industry. There are 3 principal types of specification, and we'll look at these in NBS Chorus in a moment. It's unlikely that a particular type is used purely and in isolation. It's much more likely to be a combination and mixture of various types of clauses. It is also possible to suggest that the briefing instructions about the project, the client requirements, and an outline specification of a product or system is a type of specification too. But let's look at performance, prescriptive, and proprietary specification in more detail. So here in NBS Chorus, I'm now going to take you through some of those types of specification using some examples. When you add a new system to NBS Chorus, you're presented with what we call a system outline. And this allows you to go through in a methodical way, provide some information to help you specify at different stages of a project. At the beginning, we talked about an outline description, and perhaps there might be information that you're including specific to your project to define the system based on the brief, based on drawn information, or perhaps the location of the system within your project. Then we have an area for system performance information. So moving from that kind of outline to performance way of specifying, the performance information is about the design against particular criteria. Say, for example, in this case, the color temperature of the lighting. And then the general design of particular lighting systems, or the areas that are going to be affected by particular standards that you want to reference. So within this performance dropdown, we can then choose the clauses that are relevant to us, such as design of general lighting, the lighting performance area, and lighting cables. And you build up the specification in this way. And what's worth remembering is that these are hyperlinked, so that each of these clauses is adding information to the specification, and then you can then move to that particular clause to then start developing the information in more detail, again with contextual guidance on the right hand side. Then as the project develops, it's likely you will want to start defining things in terms of prescriptive information. So we know the performance that's required. What are the products that we're going to use to accomplish that and make the system work? So here, for example, there are a number of different containment options. And again, on the right hand side, guidance associated to the specific type of system that we're referring to. Here we can see, for example, that there are already 3 different clauses for cable trays within the specification already, but we may want to add, in this case, some rigid conduit. So we can just choose the title that we want to and begin to add that information to our spec. We begin to create a more prescriptive specification. That is defining how the performance is going to be achieved based on these specific products and standards that we're going to refer to. Once we've chosen the various products and systems that we require within our project, there's then execution information to deal with the workmanship of how this is going to be installed, how it's going to be labeled, perhaps modified, and so on, so that how the workmanship is actually going to be carried out, and again, prescriptively specifying what it is that needs to be done. Again, these clauses are about specifying end results rather than how something is going to be done. It's about specifying what the outcome needs to be. And finally, we have documentation, spares and maintenance information, along with items around the testing and commissioning of these particular systems for how we're actually going to be testing that the performance is verified. So how do you ensure that the original requirements from the client, that performance information, is then verified through testing? And that's what these clauses are designed to do. We can then save our system that we've developed, and that will add these clauses to our specification. Each one of these, again, is a hyperlink to help us to take to that clause and then begin to think about what the requirements are in terms of that specific system. So let's look at an example of how that clause might develop over time into a more complete version of that system outline. And here you can see that from that same description, we're now developing a number of system performance criteria and all of the various containment and accessories and products that make up that system. And then the execution information and system completion of how this system is going to be tested and commissioned. So all of this being a prescriptive way of specifying the system that's required. The final type of specification to consider is proprietary specification, where we start to reference manufacturers. So in a prescriptive sense, where we've now chosen a suspended luminaire, we may want to define what manufacturer we're actually going to use for this particular product. And that may be done in consultation with the client or with contractors in terms of the actual manufacturer's information you're going to add. But what you'll find against a number of the clauses in NBS Chorus is that there's product information being pulled from NBS Source, our manufacturer product information platform. We're working with manufacturers to increase the amount of building services and M&E information that's available, but particularly for some items like luminaires, for example, you'll see that there's a number of manufacturers available to help you to specify these products. You can then compare different products on NBS Source and refer back to the NBS Chorus platform. And within each of those items, there's information about the product, the clause that's going to be added to the actual project, so you can see the information that's included and whether it meets your needs. And when you add that product to your job, which is as simple as clicking this plus button, you can then see that the manufacturer is then added to the clause, along with information about the contact details and the product reference, but also any of those specifics to that product that need to be specified, or that you have selections to choose from based on manufacturer options. You can then choose to park information where it's not relevant or you don't want it to publish, and continue to develop the specification in this way. This then becomes a proprietary specification of this specific luminaire, and you may wish to give it a prefix or a suffix to indicate exactly which type of luminaire this is, and allow you to reference it elsewhere in your job. In that demonstration, I was using the Uniclass 2015 content in NBS Chorus, and having a standard structure for your specification content is essential. There are many classification structures in use in the UK and worldwide, but Uniclass 2015 is the structure of choice for NBS Chorus UK and Australian content development, and it's worth introducing it if you're not familiar. Subsequent to the development of Uniclass as a collection of tables including cores 20 years ago, NBS has worked closely with industry, various organisations and government to develop Uniclass 2015, a dynamic, industry-leading, truly unified classification structure covering all of the built environment's activities and sectors for asset management. This is the NBS site for Uniclass 2015, where you can download the classification tables, including mapping to NRM, and read support articles or send queries and make new suggestions. As you can see in the section, all of the levels and aspects of the building can be classified, from spatial planning, elemental structures, to systems and manufactured products. There's some great examples of Uniclass in use out in the public domain. In particular, I'd recommend this Bryden Wood report on data-driven infrastructure for the Digital Built Britain project, which shows Uniclass being applied at every level of two particular projects, in this case the Elizabeth line for infrastructure, showing all of the various systems, products, components and how they are classified. NBS Chorus has been designed to be classification agnostic, that is, the platform is capable of supporting content in a range of classification structures. And although the UK content is natively classified to Uniclass 2015, as you can see, other classifications are available too. But also, it's important to note that Uniclass isn't sector specific, that the same coding is used for architecture, services, landscape and structural content, so that content for M&E engineering specifications, HVAC, drainage, fire extinguishing and power generation systems all have their own individual codes. Next up are a set of core editorial principles that you can use when developing your specifications, such as using clear language, specifying end results, and thinking about the formatting. A key principle in NBS specification has always been say it once in the right place, because information can otherwise end up being duplicated. This tends to be common in information that appears in both the model and the specification, or the specification and separate schedules, or the contract and the spec. Keeping graphical information in the model and written content in the spec means you're avoiding repeating the same product or requirement more than once. Even within the spec, duplication can lead to inefficiencies in changing or updating that content. So with NBS Chorus, it allows you to write a clause once and then cross-reference it through intelligent linkage and reporting. In this case, say that you had some trunking or conduit, it would allow you to cross-reference that information through intelligent linkage across the rest of the spec. Because the information model is a database of connected data, this key phrase could perhaps be updated now to say it once in the right place, but report it anywhere. It's the same piece of data that you're referencing back, not a new duplicate of it, especially in the model information. Language is so important in specs. Keep the spec concise, remove phrases like "the contractor shall do the following" and other long sentences. Like any document, for many readers, it needs to be clear and simple. It shouldn't be assumed that English is the first language of the receiver, and the number of languages other than English being spoken in the UK continues to grow. It's sensible to aim for plain English, so that all readers of the spec interpret it exactly the same. In general, this means removing legalese, terms like herewith, aforesaid, wheresoever. Instead of indicate, say show. Instead of relocate, say move. Instead of discontinue, say stop, and so on. Jargon should be avoided, along with acronyms without explanation. Equally though, the desire to write in plain English shouldn't be a reason to oversimplify a complex requirement. It's still important that the specification details the works exactly as required. Specify outcomes, not processes. It's the contractor's responsibility to decide how to install a product, a system, a material, how to cure concrete, how to achieve what the client has requested, that you document in the spec. This is one of the key ways that design responsibility can become blurred. Specifiers take on risk if determining a process, so just specify the end result you want. In this example, the end result is to have things clean, free of any traces of building work. The specifier defines what's required. It's up to the contractor for how the accessories are to be cleaned. If we consider again that the specification is an evolving set of data, later in the project it might be necessary to specify some process between subcontracts or capture a manufacturer's method or recommendation within the BIM process in order to maintain the built asset or to show how to replace an installed system in the future. But the purpose of the design specification is to specify just the end result. It's particularly helpful if you're able to reference standards, say testing, verification, or commissioning guides, that allow you to be very clear about what it is that you want to refer back to. The specification content in NBS refers to many standards and reference documents, but it doesn't cite building regulations other than in guidance. That's because it's not necessary to state legal requirements. Because those requirements are regulatory, it goes without saying, literally, that water fittings have to meet water regulations, or the building regulations generally. It's the contractor's responsibility to make sure that the works are legally compliant. What you're trying to refer to is the client requirements. One area of confusion is that the contract is between the client and the contractor. So the specification shouldn't have clauses or information directed to anyone but an imagined general contractor, not subcontractors or consultants or specialists, or even manufacturers who might indeed eventually be the receivers of different parts of the specification. It's up to the contractor to decide how and if the specification is divided up to different parties. Work packaging features and publishing options in NBS Chorus help design teams to achieve this. It can also be suggested that terms like supervise or inspect can confuse design responsibility and be difficult to achieve. This is linked closely to the specification of end results, not processes. Working in this way also allows the specification to be started as early as the first design sketches, before contractors have been appointed. Much of NBS Chorus and its workflows utilize collaborative features in the cloud, but at some point a PDF or printout is going to be produced. It's generally a good idea to make the information you're producing really easy to read and navigate. The clearer the information, the more likely somebody is going to read it and to understand it. The obvious things apply. Double check, spell check, proofread the output, especially for numerical errors, which can be easy to make, hard to spot, but can have a major impact. A consistent clear font, standard page structure with page numbers and headers and footers, and a table of contents to aid navigation. NBS Chorus allows you to now publish your own style sheets, helping you to set up all of that for your organization. The PDF in NBS Chorus outputs the table of contents as hyperlinks, which take the reader to relevant clauses rather than having to trawl through a paper document. It also avoids mistakes in cross-references, compared to writing them manually or rekeying them into drawings or Excel. Let's consider how specification evolves over time as part of the golden thread of digital information for buildings and assets. Remember that one of the descriptions of a specification was an issued document, that it involved taking decisions, recording these and communicating them at a point in time. It's equally important to consider that the specification is not just a document that exists isolated at one point. It's unlikely to be generated by just one individual. Instead, the specification evolves across the project timeline. And out of the hacker report and the information that followed, there was a lack of clarity around changes between the design and the completion of construction, that the owner and occupants didn't have easy access to up-to-date information about the building or asset, and that it was difficult to ascertain what effects refurbishment and other works had had on building safety from the outset. The draft Building Safety Bill and the information and secondary legislation will include provisions that help create this golden thread of information, something that can be held digitally and can ensure that the original design intent and any subsequent changes to the building are captured, preserved and used to support the safety improvements. There's still much to come in that secondary legislation, not least a more ambitious BIM process. If you look at standard work stages, like in this case the RIBA plan of work or the CIC stages, specifications form part of the key information at the end of concept, spatial coordination, and technical detailed design stages of a project. But furthermore, the final information exchanges of asset information and a building manual should be developments of what has been specified. Importantly, it's not that this information is rekeyed into a new set of documentation every time. It simply needs to develop in NBS Chorus as more information is added. This evolution of the specification advances the documentation and model, inputting information as the design advances. These versions of the specification are developed, perhaps as documentation, but you should be able to refer everything back to the original client requirements and also feed everything forward into the asset information required for the golden thread, like building manuals and maintenance information. So early on, say at the end of concept design stage, you know that you're preparing descriptive specifications for the ductwork and ventilation systems, but prescriptive specs for lifts and escalators to ensure that their sizing is correct. There will be this mix of descriptive and prescriptive specs when it comes to tender. Ultimately, everything turns into a prescriptive spec as it's all fully designed prior to being built, and that information should be updated and produced into record specifications. Previously, it was understood that some of that technical design would overlap, recognizing packaging and the increase in specialist subcontractor design as the project information developed. But the draft Building Safety Bill process and new regulation may influence greater scrutiny of the information available at distinct gateways before the project can proceed further. Finally, let's consider how specification is becoming a key part of a wider information model, alongside BIM processes and data development. The last decade has seen such rapid change and development in construction technology, process and procurement, all of which has an impact on specification. Technological developments in computing and modelling have had a major effect on the direction of specification writing. Specifications have to work effectively within 3D CAD platforms and your workflows. Traditionally, specification writing was done after much of the model information was fairly well developed, but now the spec can be kept in sync all the way through the process through plugins like our NBS Chorus one here, and evolve to describe what you're designing. NBS plugins are available for Autodesk Revit, Graphisource DarkerCAD and Vectorworks to help make specification decisions in context with model information, objects and details for users of those vendors, and we're working to add more to that list in time. NBS Chorus now also supports submittal reports for common data environments like BIM 360, Newformer and Viewpoint, and that's the first step in being able to integrate further with CDEs like those and BIM processes to a greater extent. If this CPD has been of interest, there's an article on our website called Construction Specifications, which I'd recommend you check out, containing some helpful tips and guidance on good specification writing. Please do get in touch if you're interested in using NBS Chorus and NBS Source, or you want any more information. Thank you.